Bismillahir Rahmanir Rahim. Assalamu alaikum students. This is Hamza Noor, and in this video I'm going to solve the question number 4 of International A-Level Edexcel P3 January 2022 paper. So it says that the growth of a weed on the surface of a pond is being studied. The surface area of the pond covered by the weed, a meter square, is modeled by the equation area is equals to ATP times e raised to the power 0.15 t over p times e raised to the power 0.15 t and then plus 4, where p is a positive constant and t is basically the number of days after the start of the study. So now here we have two conditions. First condition is that 30 meters square of the surface area of the pond was covered by the weed at the start of the study. So at the start of the study, it means that the initial moment, initial point when the study was started. So according to the condition number 1, we can say that when t is equal to 0, area is equals to 30 meters square. Okay, and then we have another condition which says that 50 meters square of the surface area of the pond was covered by the weed capital T days after the start of the study. So according to the condition number 2, we can say that when time T is equals to capital T, area is equals to 50 meters square. So the requirement of part A is to show that P is equals to 2.4. So as we know the fact that when time is 0, area is equals to 30 meters square. So we just need to plug in these values into the equation. So therefore we can say that 30 is equals to 80 multiplied by P multiplied by e raised to the power 0.15 times 0, and this whole thing is divided by P times e raised to the power 0.15 times 0 plus 4. So as we know the fact that e raised to the power 0 is itself equals to 1. So therefore we can say that 30 is equals to 80p into 1 divided by p times 1 plus 4. Okay, so we just need to solve this equation and we need to find the value of p. So 30 is multiplied by p plus 4 and this whole thing is equals to 80p. Therefore 30p plus 120 is equals to 80p. Therefore 120 is equals to 80p minus 30p, which is 50p. So therefore p is equals to 120 divided by 50. So therefore we can say that p is equals to 2.4. Okay, so we have shown the value of p as it was required. So this was part A. Alright, so now let's move on to part B. It says that find the value of capital T and we need to give our answer correct to one decimal place. So I'm going to erase the working of part A and I'm going to solve part B on the same page. As we know the fact that now the equation is area is equals to 80 multiplied by 2.4 multiplied by e raised to the power 0.15 t divided by 2.4 times e raised to the power 0.15 t and then plus 4. Okay, so now we can say that area is equals to 80 times 2.4, this is 192. So area is equals to 192 multiplied by e raised to the power 0.15 t divided by 2.4 times e raised to the power 0.15 t plus 4. So according to the condition number 2, as we know the fact that when time is equals to capital T, area is equals to 50 meters square. So 50 will be equals to 192 multiplied by e raised to the power 0.15 times capital T divided by 2.4 times e raised to the power 0.15 times capital T plus 4. All right, so all we need to do is just solve this equation. So 50 times 2.4, this is 120. So 120 times e raised to the power 0.15 times capital T plus 50 times 4 is 200. So plus 200, and this is equals to 192 times e raised to the power 0.15 times capital T. Okay, so therefore 200 is equals to, taking e raised to the power 0.15 times capital T as common, multiply by 192 minus 120. So 192 minus 120, this is supposed to be 72. So therefore we can say that 72 times e raised to the power 0.15 times capital T is equal to 200. So therefore we can say that e raised to the power 0.15 times capital T is equals to 200 divided by 72, which is 25 over 9. Okay, so far we have achieved this thing. Now we have to make t the subject. We need to find the value of t, and for that purpose we need to introduce log on both sides. So taking ln on both sides, so ln e raised to the power 0.15 times capital T is equals to ln 25 over 9. Okay, the argument of the log will be 25 over 9. So according to the power law of logarithms, 0.15t multiplied by ln e, this will be equals to ln 25 over 9, and since ln e is itself equals to 1, because log to its own base, so 0.15 times capital T is equals to ln 25 over 9, and therefore t is equals to 1 divided by 0.15, and this is multiplied by ln 25 over 9. All right, so far we have achieved this thing. So 1 divided by 0.15, and this is completely multiplied by ln 25 over 9. So 6.811, t is equals to 6.811. Therefore we are going to say that t is equals to 6.8 correct to 1 decimal place. This is supposed to be our final answer. This was part B. So now let's move on to part C. It says that the weed grows until it covers the surface of the pond. Okay. Find, according to the model, the maximum possible surface area of the pond. All right. So I'm going to erase the working of part B, and you will solve part C on the same page. As we know the fact that we want to find the maximum possible surface area of the pond. So if you just try to understand the language of the question, it says that the weed grows until it covers the surface of the pond. Okay, so the weed actually keeps on growing and growing and growing until it covers the complete surface of the pond. So therefore we can say that t approaches a very large value, meaning t approaches towards infinity. So we need to see that what happens to the area. We need to see that area approaches which value. Here we need to deal this question in a different way. Okay, so I'm going to give some detailed explanation over here. So just try to understand what I'm trying to tell you guys. If you just use the equation which is given to you in the question, that area is equals to 80 times 2.4 was 192. So area is equals to 192 multiplied by e raised to the power 0.15t divided by 2.4 times e raised to the power 0.15t plus 4. If you just use this equation, and as you know the fact that wheat keeps on growing until it covers the surface of the pond, so this means that t would approach a very large value. So we need to check what is happening to the value of area. We need to see to which particular value the area is approaching. But the issue is that if you use this original equation which is given to you in the question, where p is equals to 2.4, so what happens is that when you put an infinity over here and infinity over here as well, so what would happen is that area will be equals to 192 times e raised to the power 0.15 times infinity divided by 2.4 times e raised to the power 0.15 times infinity, and then plus 4. Okay, so what I'm trying to tell you guys is that when t approaches a very large value, so e raised to the power 0.15 times t also approaches a very large value, isn't it? Because it is an increasing exponential term, e raised to the power 0.15t. Okay, so this would be something like this, that area would be equals to infinity upon infinity plus 4. And if you add any finite value into infinity, it will also remain infinity. So therefore area would be infinity over infinity, and this case is not possible. Okay, it can never be infinity over infinity, it cannot be 0 over 0, and it cannot be minus infinity over minus infinity. These three conditions are not possible at all. Always you need to remember this rule, because when you guys will complete your A levels and you will go in your further studies in the universities, you will study the calculus courses, and in the first course, the calculus 1 course, you will study the idea of limits in detail. Okay, so you would have different expressions where the variable would be approaching towards infinity. Okay, and there you will study this specific rule that the expression cannot be either infinity over infinity, it cannot be 0 over 0, and it cannot be minus infinity over minus infinity as well. So these three conditions are not possible at all. Okay, so this piece of working is just for your extra help. I'm trying to make you guys understand how to approach this question. So this is not possible at all. So I'm going to erase this working now. This means that we cannot use the actual equation which is given to us in the question. So how to actually approach this type of question? As we know the fact that t is approaching towards infinity, and right now in the actual equation we have an increasing exponential term, which is, let's say, e raised to the power kt, where k is basically 0.15. Okay, so this is basically an increasing exponential term. And as we know the fact that when t approaches towards infinity, this e raised to the power kt will also approach towards infinity. So why don't we make an equation in which we have a decreasing exponential term instead of an increasing exponential term? Okay, what I'm trying to say is that when t is approaching towards infinity, we need to simplify our equation into such form where we have e raised to the power minus kt, where k is basically 0.15, and we need to see what happens to the value of e raised to the power minus kt. Okay, so this is basically a decreasing exponential term. Decreasing exponential term. And as you know the fact that if you make a decreasing exponential graph, so this is something like this, that when t approaches a very large value, it goes towards infinity. So e raised to the power minus kt basically approaches towards 0. And then we would have a decreasing exponential term, and we would be able to solve the equation, and we would be able to tell that to which value the area is approaching. So our intention is to convert this original equation into a form where we have a decreasing exponential term. And again, I'm saying that this extra piece of information, extra piece of working is just for your help. Okay, I just want to make you guys understand how to, deal with such type of question. All right. So I'm going to erase this working again. And now I am going to actually perform the steps which you are required to do in the exam. All right. So I'm going to simplify this original equation in such a way that I am left with e raised to the power minus 0.15t. And for that purpose, the step which I'm going to perform is that multiply the numerator and the denominator of the fraction. Multiply the numerator and denominator by 1 over e raised to the power 0.15t. Okay, or you can say that divide the numerator and the denominator by e raised to the power 0.15t. It is the same thing. So area is equals to 192 multiplied by e raised to the power 0.15t divided by 2.4 times e raised to the power 0.15t and then plus 4. So the step which I'm going to perform is that multiply 1 over e raised to the power 0.15t with the numerator and the denominator as well. Because if you don't perform this step, you would not be able to tell to which value the area is approaching, as we have seen earlier. Okay, because infinity over infinity is not possible, 0 over 0 is not possible, and minus infinity over minus infinity is also not possible. These three cases are not possible. So this will become area is equals to 192 divided by 2.4 plus 4 over e raised to the power 0.15t. So this is basically the same thing as saying that area is equals to 192 divided by 2.4 plus 4 times e raised to the power minus 0.15t. So now here we have successfully achieved a decreasing exponential term in our equation. So now we are going to say that when t approaches a very large value, e raised to the power minus 0.15t approaches towards 0, because here we have a decreasing exponential term e raised to the power minus 0.15t. Okay, if you put in your calculator e raised to the power minus 0.15 multiplied by 100, assume that t is 100. Okay, so here you have 3.059 multiplied by 10 raised to the power minus 7. Okay, it is a very small value. So we are going to say that when t approaches towards infinity, e raised to the power minus 0.15t approaches towards 0. Okay, so therefore we are going to say that area approaches 192 divided by 2.4 plus 4 times 0. In place of e raised to the power minus 0.15t, we will substitute 0. So area is equals to 192 divided by 2.4. So area approaches 80. The maximum possible surface area of the pond is 80 meters square. Therefore, the answer is 80 meter square. In this way, you are going to solve this particular part. And this was just worth 1 mark only, but this particular step was important. Okay, and in order to make you guys understand how to deal this type of question and what is the need of performing these particular steps, I've given some extra explanation as well. All right, so this was basically the question number 4 of International A-Level Edexcel P3 January 2022 paper.